Okay, I've got some data here that comes with SPSS. I've loaded the file in. It's called car_sales. And what I'd like to do is a simple t-test comparing the mileage. Here's the mileage in miles per gallon, fuel efficiency they call it, between trucks and automobiles, so two different types of vehicles. So what I'm going to be doing is comparing the mean fuel efficiency for trucks against the mean fuel efficiency for a car. I'm just going to go up to Analyze, and I'm comparing means. They are independent samples, which really means that they are not the same vehicles. I've got one group of trucks and one group of cars, or automobiles they call it. So my test variable is going to be I'll just make this bigger. There we go. Our test variable really means the dependent variable. And I'm looking for fuel efficiency, which is right here. And you can click it and drag it over, or you could have used the arrow and arrow it over, or you can just double click on it. Okay, you can't double click on it. Okay, there it is. The grouping variable is really how you're making your two groups, and I'm doing it on vehicle type. That's the variable. Where is vehicle type? There it is. I put it down here, and what you'll notice is it's got a couple of question marks, and we can't hit OK. So we've got to define what our two groups are. So I'm going to go to Define Groups, and one's called a truck and one's called an automobile. And I don't know how these are coded, so I'm going to say Cancel. And I'm going to right-click on Type. Variable information comes up, and I'm going to left-click on that. It opens up information about the variable, and it says that it's coded 0 for an automobile and 1 for a truck. So my grouping is 0 and 1, like this. I'm comparing 0 to 1. And then I'm going to hit Continue and OK. And what we see here are, first of all, our vehicle type is automobile or truck. There's 114 automobiles and only 40 trucks. It gives the mean miles per gallon for automobiles as 25.3. The mean fuel efficiency for trucks, 19.7. So certainly trucks seem to be getting fewer miles per gallon, so less efficient than are the automobiles. But is this difference real, reliable? Is it something that could have been just a fluke? And that's what the t-test is going to tell us. It's going to tell us whether or not this difference is simply a fluke. The t-test is down here, and we're looking at fuel efficiency as our dependent variable. And we've got two rows of t-tests. One of them is equal variance assumed. The other is equal variance not assumed. To answer the question as to which one we use, we'd go to Levine's test for equality of variance. No, I don't want to do that. Levine's test for equality of variance, one of the assumptions of a t-test is that your two groups, automobile and truck, will have similar variability in fuel efficiency. And if we look at the standard deviation of these two groups, we can see 3.6, 3.1. They're pretty close. And the test will test whether or not they're close enough that we can consider them equal. And it calculates an f, just like any other kind of f. It's how big is this f? And this f is pretty small, 0.004. Is it significant? Well, the question is, this is your p-value. Is this value less than 5% of the time, or 0.05? It's not. It's saying that this could happen all the time if the null were true. And the null in this case is that there are equal variance in the two groups. So we're good to go. This is telling us that we can assume equal variances and use this t, 8.664, with 152 degrees of freedom. The probability here is a two-tailed probability. No, I don't want to do that. A two-tailed probability. If you had a direction for the your hypothesis testing, and you may well in this case say we were testing the trucks would get poorer mileage than cars, then you divide this in half. It doesn't really matter at this case because both of them give you a p-value of 0.000. What does this mean? it means the probability that you get a difference in means between cars and trucks this big, 25.3 to 19.7, it would only happen by chance about 1 in 10,000 times, well, actually less than that. So it's probably not a fluke. It probably is a real difference.